Yeah, hello everyone. I'm Bernd. I'm from de-cix. Thanks for having me here. Thanks also Christian. I'm also from Austria, so this is a bit the Austrian hour here. Thanks for having us. The presentation is about a bit, or a part is about this thing which is called maps, and the other part is a bit about enterprises. And I will try to explain what has this to do with each other. The presentation was originally held at GPF, so some of you I remember which might know the presentation already. About myself, I'm in this industry for around 30 years. I love peering. My favorite book was the Internet Peering Playbook from Bill Norton that brought me into this topic here. And I'm happy to work for de-cix for the pre-sales and consultancy team. This here is the only marketing slide, I promise. So this is what de-cix is doing. Yes, we are doing internet exchanges. I think this might be well known. If not, then please grab us in a coffee break. Then we tell you more about this. So coming to the presentation itself. So yeah, part 2, and yes, there is a part 1. Let's start with part 2 for a second. So this is maps. What does it mean? So that's the Microsoft Azure peering service. The important thing is it has absolutely nothing to do with Azure. So that's the interesting thing in this name. So for whatever reason it was named like this, but yeah, that's what it is called. And it's targeting enterprises. But step back to part 1. Before we come to maps itself, we need to look a bit on the enterprise topic itself. And let's start with this question here, or this theory. So the question is if today's internet is sufficient for the enterprises with having so much different needs and so much different content or targets. Is it okay to say one internet business access fit for every customer, for every situation? So that is a main question which has to do with this presentation. So when we look at this picture and find an analogy here, so I chose the bus here. So when we look at the internet, this means we have 75,000 stops to drive to, which are the number of ASN what we have in the internet. So we have one driver, which is the ISP, which is the bus driver, and we have M passengers. So the question is, how do you manage to drive the one bus with one driver to these number of stops? So that's what we are looking at when we look at the internet routing table. So bringing it a bit more into this picture here, especially when we look at these new home office things. So now we have a lot of employees sitting in home offices at whatever ISPs. So that raises an interesting question, and that's also part of our daily discussions with enterprises. So now they have their staff workers sitting in whatever ASNs, which are the ISPs, and the question is, what's the distance from the internet access, from the headquarter, from the business access to all those ISP networks? So as you see here, there might be ISP number 1 with the green pass, where the bus is having a nice shortcut, a short route. So all the users which are using ISP number 1, they are for sure happy. Then you might have the ISP number 2, which has a bit, maybe more a zigzag to reach, and the bus takes a bit longer. So maybe there are still some users or staff workers fine with that, or maybe the first ones have issues. And ISP number 3, which is very far away and with a weird routing, very bad reached or with packet loss, those users or staff workers are for sure not happy. So what's the new reality or the possibility for enterprise customers? And staying with our analogy, now the first enterprise customers bought a car. A car means, in this analogy, they bought a router and they have a driver license, which is the ASN. So hooray, now they are happy to drive themselves, but of course not for each and every of the 75,000 destinations. So they are still driving with the bus, but now with having their own car, they are able to drive some shortcuts on their own. So that might help to get rid of some nasty problems which they cannot fix with the other way. So the topic is enterprises are coming to an IXP. So that is what we see at de-cix for a longer time now, and it's not stopping. So that's a trend, I would say. So putting now the maps topic into the scene. So how does this compare here? So when we look at this historical way how enterprises built their networks and partially still run, so there is this idea of central internet breakout, especially when it comes to resources like Microsoft. So you find this still often. And if you tunnel all your remote destinations in VPN or in MPLS or in whatever, and you make huge distances, that might not be a good idea for those users which are far away. Then enterprises also have often this here, this delay stacking thing. So for whatever reason, they have an ISP which is from a total different region, might have something to do with global contract of the system integrators or whatever. Then they have a security outsourcing specialist to run the firewall in whatever other country, and then you have whatever other applications which are also part of that. So that's a real case. We had traffic crossing many times zigzag through Europe before reaching the internet. That might also not go well in enterprise scenarios. So summarizing quickly a few of these challenges. So enterprises have demand for ultra-low latency for various applications. They have issues with the global stretch of their network. All these different clouds, multi-cloud, cloud first, whatever, also is part of that topic. The home office users are now sitting in whatever ISP networks. And of course the question of real redundancy. So real redundancy means there is a BGP in place and there are two different operators in front. That would mean real redundancy from an engineering point of view. So enterprises are coming to the IXP. So what now? That was the simple old picture. So we had the IXP, we had the eyeballs and the contents. These were the two main groups, partially with some resellers in between, and that was simple. So now we also have the enterprises. The content has split into content and cloud, and resellers are also acting on all stages. So that brings a whole new complexity also to internet exchanges, and this is what we are constantly working on. So also interesting to look at when we try to understand enterprises might be these topics here. So from the first line, from the doing and from the setup thing, the old world, from ISPs, from CDN, from cloud, everything was simple, so well understood, everybody knows what to do. If you talk with enterprises, nothing is clear on that side. From the doing, from the setup, from the config, from who does what, everything is confusing. So there is a lot of questions how to bring an enterprise into a BGP multi upstream peering and whatever. From IP side, from ASN side, this is quite simple for the old world. For enterprises, it might be a challenge to run through processes like getting RIPE. I know from various enterprises, the first thing they try to do when opening a RIPE layer is the legal guys taking the contract, rewrite the RIPE contract, and then are disappointed why RIPE doesn't like their new LIR contract. So there are various challenges bringing enterprises to IP and ASN resources. Peering manager, well known in the old world. Peering manager is not known to anyone in the enterprise side. Big router, the next topic, quite standard. If you talk with an enterprise, why they should load 2 times a full table into their router, which is in their meaning a firewall, and then the firewall admin says, hey, you're not loading a full table in my firewall. So there are a lot of technical things on that side. SLA, it's a good understanding how to deal with SLA on the on IXPs or similar infrastructures. With an enterprise, we have the discussion. This is pure 100% SLA. Everything else doesn't fly. Session down, the next big thing. If there is a session down, the ISPs are very knowledge with that, so you open a ticket or maybe just wait 5 days and everything comes back or will be handled. If a session goes down in an enterprise environment, there might be a big hello with a lot of people, a lot of tickets and urgency and alarm. So these processes are also quite unknown. Implementation, one person is enough, I would say. If you ramp up this with an enterprise, you find yourself in very big meetings with a lot of teams, not even with a lot of people, a lot of teams. So that's something we have to deal with when we have enterprises in that environment. So coming to the part 2 with the maps itself. So now we understood a bit the basics of the enterprises. So let's start with some initial statements. As we are looking into maps, so this means this all has to do with Microsoft, and these statements are also validated with Microsoft itself. So Microsoft has not fun to peer with enterprises on IXPs. In some exceptions, they might have done this, but generally it's not their wish that this goes this way. Then enterprises, as already mentioned, if the session goes down, that's an issue, and Microsoft cannot help the enterprise if this happens on a peering. So peering is somehow best effort with some generic processes. If the enterprise peering session falls down and you call Microsoft, and Microsoft will not know you, who you are and what you mean. The enterprise always needs an SLA, end-to-end backed solution, that's clear. Microsoft cannot help or debug if you come as an enterprise via an unknown internet bridge. So unknown internet bridge means a generic standard IXP or a root server. Yes, Microsoft is typically not on root servers, but there are still exceptions out there. So that is, Telemetry option, also an important topic. Telemetry option is only available via this Microsoft Maps product. We will see that in short. And we have the next statement about this 10 millisecond thing. So Microsoft told us it's their plan that each enterprise user or network should be in a distance of 10 milliseconds, which is around about 500 miles or 800 kilometers next to the nearest Microsoft Edge router system. I'll come back to that in a second. Also important, maps means you're peering with Microsoft 87.5. So if an enterprise network is doing these Microsoft Maps peering service, he peers with the global Microsoft network, which means everything from Microsoft. All their content, all their whatever, even Xbox and service packs and whatever is running around in Microsoft Azure, Microsoft 365, etc. So it is also needed from the design guys where to connect what. So we are not talking about an express route, which is a total different thing, which is going more or less behind the firewall or in a DMZ environment. This here is on the edge of the network. And then again, this 10 milliseconds to look into the picture how Microsoft understand this, or what's the idea here. So the idea from Microsoft was that enterprises bring their locations as they are, country by country or region by region, to the nearest Microsoft Maps on-ramp. Yeah, if we transfer this picture into Scandinavia, so this would mean a production site in Finland should ideally go to an IXP or Microsoft Maps on-ramp. Here in Finland, the facilities in Sweden should go to the IXP, which offers a Maps service, should go there, and same for Norway or for Denmark. So this means the enterprise should bring their network side by side to these nearby Maps on-ramps. So that's the 10 milliseconds distance target. A quick info on the setup. So how does the Microsoft Maps setup look like? And I talked also with the colleagues. Everyone built it this way. So you have these encapsulated, dedicated environment. There you have or find dedicated root servers. They are already preloaded with all the Microsoft Maps prefixes, with the global ones. And in the moment where you are provisioned into the Microsoft Maps product, then you're automatically immediately peered with Microsoft. Of course, only in the case if your IRR and RPKI was done properly. So that's a standard setup which is equal all over the world. And what's about our ISPs now? They totally hate us. No, absolutely not. Why? Because the enterprise need this layer 2 circuit to reach the Maps service, and guess where they will buy it from? Of course, they will talk with their ISP. So the ISP has the option here to sell the layer 2 bridge to the IXP, which is an extra service, and it makes sense because it solves a problem on the enterprise side and it brings some new revenue for the ISPs. So everybody wins here. And there is also space for those who are very creative and see themselves in this reseller corner or have ideas on how to rebuild these for other products. Yes, you can take the Microsoft Maps service and build your own whatever aggregation topics on that. Telemetry option, Microsoft put this in this Azure portal. So as a Maps customer, you find all this telemetry information in this telemetry option part where you find the latencies from the perspective of Microsoft. So if something goes wrong with your Teams calls or your Microsoft 365 doesn't work, then you find here what latency does Microsoft see to you. And also here you can open directly the ticket, and this is the difference to a standard peering. Here Microsoft will know who you are. You can open a ticket and they will find it and they will work on that. So how does it help the enterprise, to summarize that. First, the layer 2 link has the advantage it doesn't change its latency, and you can contract it down to the should be latency. Even the backup layer 2 pass, it's always built redundant. That also has a predictable fixed latency. All components are coverable with SLA end-to-end. The enterprise has the possibility to call someone 24/7. There is the telemetry dashboard showing the details. It's DDoS safe because it's a dedicated capsulated environment, and no additional costs on the Microsoft side for the enterprise except the service itself. Looking at an example graph, so how does this look like at the typical enterprise customer? So it's not a surprise. Everybody comes to the office in the morning, so 7 in the morning, 8 in the morning, traffic goes up. Then, of course, there is lunchtime coming, a bit less work on the afternoon, a peak for whatever reason between 5 and 6, and then in the night, maybe some backup jobs running, and then it starts all over again, and there was maybe an event or something special, whatever. So, yeah, it's a as expected traffic graph from an enterprise. And this is all Microsoft traffic then. How about redundancy? Redundancy is simple because we are looking at the standard BGP setup here. So this means if the Microsoft Map service would go away, even with being redundant, if you run BGP as an enterprise, okay, you have solved hopefully your multi-homing anyway. So this means Microsoft is your preferred first choice, and then you have 2 IP transit providers as second and third, and your ISPs have for sure a Microsoft peering themselves, which would be able to catch whatever happens here on that side. So the full chain of redundancy with BGP is very good covered. What else? As we now have the enterprise on the Internet Exchange, yes, there are a ton of other ideas what can be done in addition. So, of course, all these cloud options, so there are different clouds, yeah, you know them all. So they are just one configuration away from the trunk port. So the enterprise is on the IXP fabric. The cloud providers with Cloud Connect product are also there. So whenever, whatever Cloud Connect is needed, that's simple doable then. And not to forget, on the IXP, we also find other special groups which are also very interesting for enterprises, like all these financial ASN, like Salesforce, SAP, whatever, banking, stock exchange. So that might be interesting for an enterprise network, or all those anti-DDoS specialists, which are also part of an IXP environment typically. So that's very easy to interconnect these systems, or backup to the cloud can be peered via the IXP. And yeah, here they find the ISPs where their staff workers are sitting in the home office. So that's a full range of possibilities, and a full range of possibilities to make services as the ISP, or maybe you're offering services there because that all needs someone who knows how these things are done. Customer feedback. The first one is, yeah, this is our case study from nog.fi, a big construction company. They had from Frankfurt to Frankfurt these 50 millisecond latency, which went halfway through Europe, and at the end it was 5 milliseconds instead of 50. The VPN stability improves. It's a stable, reliable path. 60% of the traffic went to Microsoft already. That's what the customer told us, and the price argument. Well, that's it from my side. Thank you.